Section 4 in Module 1 is on distance. And let's get started on distance. And so first, let's understand what we define as distance here in geometry class. Distance is the distance between 2 points is the length of the segment between the points. All right, so we're going to talk about distance in a lot of different ways, but we're going to talk about distance as a form of length. Now, there really is something here called the ruler postulate that we're not going to get into. All right, essentially think of it as this. Distance in geometry class always has to be a positive because we're measuring things that exist in real life. And so if it exists, you can see it, and therefore the distance cannot be a negative number. And that's the basics of where we're going to start out here with a number line. All right, and so the book is just saying if you have from P to Q, you can just find that measurement by subtracting. Now, the book says it doesn't really care whether you do x2 minus x1 or x1 minus x2, but you got to use the absolute value. Right? And so I always say x2 minus x1, but let's just kind of look at one example real fast and make sure we understand why absolute value. And so I'm going to give myself a real quick number line. And this is -5, -4, -3, -2, and this is -1, and this is 0. And so I'm going to put a point here. All right, we'll call it A. And I'll put a point here, and I'll call it B. Okay. And so if I want to measure the distance from A to B, right, I want to do -5 minus the absolute value of -5 minus -1. Okay. Now, hopefully you know that minus and negative inside here becomes a plus, and so you get the absolute value of -4, which just means absolute value is always positive. It doesn't switch positive to negatives, just switch negatives to positive 4. Or you could count, if you prefer, you can have a number line, you count. It goes 1, 2, 3, 4. The distance from -1 to -5 is 4 units. And so this little quick formula will be always the math that works out to the answer. Some of you won't have to do all this math. You can kind of either see it or just in your head, you do it faster than that. But there is an equation for those of you that need it here that always works. Let's look at an example of what I mean. All right, CF. C is right here at -1. F is right here at 5. So if I want to find CF, I'm going to go 5 minus -1. All right, again, it's absolute value. Minus a negative, again, becomes plus. And so 5 plus 1 is 6. The absolute value of 6 is just 6. And so that is my answer here. It is 6 units long from -1 all the way out to +5. 1, 2, 3, 4, 5, 6. All right, you give it a try. Let's find AE. Find AE. Pause the video now. Give it a try. All right, if you haven't already tried, continue to pause, but let's count it out. A to E, 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I would have done 4 minus -5, which became 4 plus 5 is 9. Anyway, here I would have gotten D as my answer. Okay. Now, this is using that same fundamental now to compare two things and ask if they're congruent. And so first, let's look at CB. CB is -1 minus -3. Now, it's the absolute value of that. Again, I got to make this a plus, and so I get 2 there. The absolute value of 2 is just 2. All right? And then I want to compare DF. Well, let's use a different color. DF. All right? D is at 2, F is at 5. And so for df, I'm doing the absolute value of 5 minus 2, which is the absolute value of 3 or just 3. Now, those are different. If they're different, then it's not. And again, this little equal sign with the squirrely means not congruent. And so that is my answer, not congruent. The next one, you try it. Pause the video here. I'll read it for you, and then let's pause it and go for it. The coordinates of Q and R are at negative 7 and 12. The coordinates of S and T are at negative 3 and 16. Are segment QR and segment ST congruent? And if they are, what is the length of each segment? Pause the video, give it a try. All right, I'm going to go over it. If you haven't, continue to pause here. Each one was 19, and so my answer is yes, 19. Make sure you picked positive and not negative 19 for this example. Now, let's talk about distance on the coordinate plane. And the formula down here at the bottom, I'm going to rewrite up here. All right, the distance formula for an coordinate plane. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, that's down here at the bottom. They said for PQ, but that formula works no matter what. That needs to be in your notes. Remember, quizzes are open notes. It'll probably be provided for you on the test, but not on a quiz. So when you have to do distance on a quiz, if you don't have the formula, you're kind of up the creek without a paddle. And so have the distance formula down. X sub 2 minus x sub 1 squared. Now, what does that mean? In case you forgot from Algebra 1 class, the x and y's just come from the same place. So the 1's are married till death do them part. The 2's are married. It doesn't really matter. You could call these the 2's and these the 1's. All right? But what if it's x2, then it has to be y2. If it's x1, it has to be y1. Right? And so you're either working from right to left both times or left to right both times. Let's look at an example of what I mean. And I let the book, I don't know why the slide's there. Let's just cross this slide out. This is old notes. I apologize that it's here. Right? And so I left all the book to show all the work here because the book writes nice and neatly, and I don't always write so nice and neatly. All right. And so the book here is just saying, hey, 4, we're going to call 4x1. So this is my x1 right here. And that means that this is my y1. Right? And then the book's going to say, hey, this is my x sub 2. This is my y sub 2. And then they just plug it in. x2. x2 is negative 3. So negative 3 goes in. y2. y2 is negative 7. So negative 7 goes in. x1. x1 is positive 4. So that goes in. y1 is positive 3. So that goes in. And then do the math. Negative 3 minus 4 is negative 7. Negative 7 minus 3 is negative 10. When you square them, negative 10 to negative is a positive, so it just ends up being positive 49. Negative 10 to negative is positive, so it just ends up being positive 100. You end up getting the answer of square root of 149. Right? Do that in a calculator, and my answer ends up being 12.2. Now on the test, the book might leave it in square root form, multiple choice, or they might put it into use the calculator, 12.2. Right? And so I gave a U-tray here, but let's work through it together. All right, let's make sure we're on the same page. So first thing I need to make sure I'm going to write down that distance formula for myself. All right, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And you know this is my x1, y1. This is my x2, y2. So to do the math, distance equals x sub 2, 5, minus negative 4 squared. plus y sub 2, negative 1, minus negative 6 squared. And again, it's all under the square root sign here. Okay. And so square root 5 minus a negative becomes a plus. So that ends up being 9 squared. Minus a negative ends up becoming a plus. Negative 1 plus 6 is 5 squared. 9 squared is 81, plus 5 squared is 25. I add those together, I get the square root of 106. I grab a calculator. What is the square root of 1.6? I got 10.3. So take your time, plug in, and work it out, and use your calculator, and you will get the right answer. So working on distance today from section 4, page 31, 1 through 6 all, and then 16 through 26 even. Again, I need to see work on problems that require some work. So all the ones with distance formula from a coordinate plane, I want to need some work. I would suggest highly that you use a piece of paper to write these because the workbook doesn't have enough space in it. All right, and then you can take a pic and submit that on Schoology.